Hey everybody, welcome back. We are now doing part two of law of cosines. Here we have a situation where triangle ABC has a side AB, BC is equal to 10, and AC equals 12. What is the measure of angle B to the nearest degree? Well, let's take a look. Again, we are going to be drawing a diagram. Okay. And so let's see now. Let's make this AC. This is B. So here, this is a 12, BC is 10, and AB is 8. And so now we're saying to ourselves, can't use law of sines because there's no angle. Well, maybe use law of cosines. Now, if we're focusing on angle B, this is angle B, sorry, it's a pretty bad angle B. We know that B squared minus, B squared equals A squared plus C squared minus 2AC cosine of B. Well, what we can do is we can move things around by, for example, I'm going to add 2AC cosine of B to both sides. So now I have 2AC cosine of B plus B squared equals A squared plus C squared. Now I'm going to subtract B squared both sides. Now I have, in this case, I have 2AC cosine of B is equal to A squared plus C squared minus B squared, and then divide everything by 2AC. And this divides out, and now what I can do is I can enter in the information of A, C, and B, and here, and find what the cosine of B is going to be. So we're going to get in this case, the cosine of B is equal to, now A, opposite of, this is A because opposite of angle A, and we know this was C, opposite of angle C, and this is B, opposite of angle B. So we have in this case 10 squared plus 8 squared minus 12 squared all over 2 times 10 times 8. Now, one of the things I would recommend is that you find the values separately. So we have cosine of B. So on our calculator, let's pull up a calculator. So 10 squared plus 8 squared minus 12 squared. So let's see. Oops. Sorry. So 10 squared plus 8 squared. Ooh, not 5. 8 squared minus 12 squared. Okay, so I'm going to find this value separately. So enter, I get 20. Wow, okay, so I'll get back to here, 20. And then we do 2 times 10 times 8. That's going to be 160. All right, just to make sure. 2 times 10 times 8. 2 times 10 times 8 equals 160. So now what we want to do is we're going to do second cosine of 20 over 160. So second cosine of 20 divided by 160. I don't need to simplify. Everything is going to be found by itself this way. And we find ourselves with 82.8192 degrees. So here, to the nearest degree, because cosine negative 1 of 20 over 160 is approximately 82.8. So we said 82.8, so we'll round to 8. So we'll round that to 83 degrees. But what happens is that it's a lot of moving things around, but we'll notice the pattern here, okay? We'll notice the pattern. That cosine of B was equal to A squared plus C squared minus B squared over 2AC. Well, we can do that with all the angles, and in this case, if we know all 3 sides of a triangle, we can use law of cosines to find any angle of the triangle, where cosine of C is A squared plus B squared minus C squared over 2AB. cosine of b equals a squared plus c squared minus b squared over 2ac. And cosine of a is equal to b squared plus c squared minus a squared over 2bc. So you're saying, well, how am I going to memorize this? Well, notice in this situation, when the angle you're trying to find, here's angle C, you always have the minus the side opposite squared. Here's cosine of B minus B squared at the end, and cosine of A minus A squared at the end. And the other two letters are being squared and added in this case. Other two letters being squared and added in this case, so. And then divide by 2 times the product of those two letters. Here, a squared plus c squared, and here's 2ac, b squared plus c squared, 2bc. And so it comes down to, in this case, let's say look at the first one, angle C, cosine of C, and we're going to find, in this case, we see that it's a squared plus b squared minus c squared, okay, over 2ab. And so you still have this situation where it looks like side angle side, because that's how they looked at, though. Law of cosines kind of follows along the side angle side information. But here, it also works for the another way of looking at triangles, side, side, side. If I have 3 sides of one triangle, I know the measurements, they correspond to 3 sides of a triangle. The triangles must be congruent. And so we don't have any ambiguity for the law of cosines, because law of cosines usually uses side angle side or side, side, side. And those methods are, when we talk about proving triangles congruent, it's usually not a big deal. Okay? All right, so let's practice a little bit. All right, so let's see. So we go, okay. All right. Let's see now. Let's try out some problems. Okay, let's see. Should we try out this one? So we have 3 problems here. And so here we're going to find measure angle C. And if you remember, we said cosine of C is equal to a squared plus b squared minus c squared over 2ab. And so for number 1, cosine of C is equal to 3 squared plus 4 squared minus 2 squared over 2 times 3 times 4. Well, that's equal to 9 plus 16 minus 4. That's 25. 25 minus 4 is 21. And here we have 2 times 3 times 4, that's going to be 24. So we're going to find cosine -1 of 21 over 24. Now, one of the things I'll be very careful about is that I don't want to type this on my calculator. I could, be super careful. I like finding each one separately because this way I don't have to worry about making errors. Okay, because calculator is not wrong. It's based upon what you type in, and so the order of operations becomes a little tricky. So I, for the most part, want to make sure that I type in the correct values. So 21 divided by 24, and we find in this case our angle measure is going to be 28.95, which to the nearest degree would be 29 degrees. Okay, so here the measure of angle C equals 29 degrees. Okay, well now let's make some changes. So we'll do number 2 now. Okay, for number 2, we're going to, again, only a slight change here. Okay, notice in this case that C started at 2, and C was the smallest angle in this triangle. So, so in this situation, we're only going to be changing C value. So I'm just going to change all the C values here. And what it's going to do is to change just the values on top. So we'll see how that works out. So erase all the stuff here. Everything else remains the same. So this way we'll take a look. And so here I'm going to use a different color. In this case, I'll use red. And so here we'll do 5 squared and 25. All right. So 9 plus 16 minus 25, that's 0. What? So cosine -1 of, oh, I'm so sorry. That's not 0. Yeah, it's 0. Because 25 minus 25 is 0. So here, cosine -1 of 0 over 25. Okay, so second cosine. So second cosine and that's weird, of 0 degrees, well, 0 divided by 24, we're going to actually get a value of 90 degrees, okay? So here, our answer is 90 degrees. And it kind of makes sense because look at this, it's a 3, 4, 5 triangle, and so C is the opposite of the largest side, this 3, 4, 5 triple, the Pythagorean triple, it will be 90 degrees. Okay, one more. So we're going to follow the same way. We're going to do, in this case, this time we're going to erase all the stuff here, and we're going to change this to, in this case, instead of being 5, we're going to change it to 6. Okay, so here we go. Do this in green. 6. 6 squared is 36. Now 25 minus 36. Well, that's, I think, negative 11. And now you're saying, what? I can have negative numbers? Yes, actually. So we plug in negative 11, and now here's what we're going to notice. Okay, so second cosine of negative 11, the negative button's down here, 11, divided by 24, and we get 117.2796, so on and so forth. Round to the nearest degree would be, in this case, 117 degrees. Okay, and so we saw in this case each time that as we, notice how the angle got larger and larger as our side opposite got larger and larger as well too. Okay, so this is the use of law of cosines. So we saw that we say change one slight thing, that how the values are, but we're keeping everything the same. Well, let's do one more problem here. Isosceles triangle RED, red, RE and ED must be the same, and RD is 8. So and RED, ED both 5, find the measure of the vertex angle of the nearest degree. Well, in this case, RE and ED, that must mean E is going to be our vertex angle, because here we have R, and both RE and ED, both the same measure, and being 5. And RD is 8. And we want to find the vertex angle, and that's usually the angle opposite the non-congruent side. So this will be our angle here. So we're going to use cosine of angle E is equal to, now the side next to it, adjacent, 5 squared, plus 5 squared, minus the side opposite, 8 squared, all over 2 times 5 times 5. See, again, what happens is that the sides here that surround the angle are going to be the sides that are going to be added here. Okay, and the side we're looking for is the ones to be subtracted here. Okay, and so let's now find this. Okay, because it's a little messy here. So, all right. So we know a cosine of E is equal to 25 plus 25 minus 64 all over, in this case, that would be 50. So now if we work this further, we'll find in this case that the cosine of E equals negative 14 over 50. Okay, let's find that now. Second cosine, negative 14 divided by 50. All right, and we find out our angle is 106 degrees. To the nearest degree, we find the measure of angle E equals 116 degrees. So we are able to find the law, find angles if we have all three sides, the law of cosines with our new rearranged formula, not only new, rearranged formula of our law of cosines. Hopefully this will be helpful when we solve problems, okay? And so now we know how to find all the sides and angles of any triangle, no matter what kind of triangle it is, with our law of sines and law of cosines. Okay, ladies and gentlemen, if it was helpful, please hit the like button and subscribe to the channel. We appreciate any comments. Leave them in the comment section below. Thanks for watching, and again, please take care of yourselves and be safe.